Hello dear students, myself Dr. Biswambhar Mohanty. Today I'll discuss a problem JEE Advanced के लिए JEE Advanced में 2024 में as it has been asked. So basing upon the और तो बेस कर रहा है जो इलेक्ट्रोस्टैटिक्स में. So the questions पूछा है क्या है ना, two bits each with charge small q and mass small m are on the horizontal frictionless non-conducting circular hoof of radius r. One of the bits is glued to the hoof at some point. One of the bits is glued to the hoof at some point, while the other performs a small oscillation. One of the bit is glued at one point, and other performs small oscillation about the equilibrium positions along the hoof. The square of the angular frequency of small oscillation is given by dash. So this is this question of पूछा है JEE एडवांस से PIQ में 2024 में. So कैसे हम लोग उसको सॉल्व करेंगे, देखो. So this is a hoof. So question दिया है, one of the bit is having the charge q is glued, is fixed, and the other charge particle makes a small oscillations about the equilibrium positions. So one of the glued is fixed, one of the charge is fixed, glued is fixed at one point, and other make a oscillation about the equilibrium position. So what is the equilibrium position? Equilibrium position का मतलब क्या है बेटा? Where the potential energy is minimum. So you know that basic concepts of the potential energy, that whenever the two Q1 and Q2 are the two charges separated by certain distance apart, its potential energy 1 by 4 pi epsilon 0 Q1 Q2 by R. So when the distance is maximum, the potential is minimum. So one of the charge is fixed, glued at one point. This is the horizontal hoof. This is not vertical, this is the horizontal hoof. And other is makes a small oscillation. or other charge particle है ना, वो small oscillation करता है about the equilibrium position. So equilibrium position कैसे हमको निकालना पड़ेगा बेटा? बच्चे लोग, हमको कैसे equilibrium position को निकालना पड़ेगा? You know that the basic concept of equilibrium position is where the potential is minimum. Potential minimum is distance is maximum. So whenever the charge at other charge is placed at that point, you place that this is the distance, and if it is placed at this point, this is the distance, and this is the distance of the two charge particles. If it is placed at this point, this is the maximum distance, where maximum distance means potential is minimum. So other charge particle should be placed at the equilibrium position में हमको रखना पड़ेगा. So equilibrium position कैसे निकाल पड़ेगा? Distance will maximum होगा तो equilibrium position होगा. So distance maximum means that is 2r. First thing, you'll have to find out the equilibrium positions. So this charge particle, this is fixed, glued, and this charge particle makes a small oscillation about the equilibrium position. So this is the equilibrium position where the distance of separation between the two charge particles maximum, then the potential energy will be minimum, then this will be the equilibrium position. This is the first concept. Then this charge particle is movable, is slightly make an oscillation about the equilibrium position. Suppose this is slightly displaced phi. This charge particle is slightly displaced phi. So what is the reason? क्यों वो तो चार्ज पार्टिकल ऑसिलेशन करेगा, कैसे ऑसिलेशन करेगा? That's only some restoring force which is responsible for bringing the charge particle to the equilibrium position. That is why the body will execute as such, otherwise not. And this oscillation, this angle should be very small, within 4 degrees, very small. for oscillations. And this is the oscillation, this is the equilibrium position, and initially the charged particle Q and is displaced at this point positions, slightly displaced. So पहले से चार्ज पार्टिकल इक्विलिब्रियम पोजीशन था, उसको हमने डिस्प्लेस किया हाई एंगल में. वाई एंगल में डिस्प्लेस किया तो एसएचएम करेगा, कैसे करेगा हमको निकालना पड़ेगा. एंड वी हैव टू आल्सो फाइंड आउट द condition of SHM and its angular frequency. So basic concept is that suppose this is this angle, suppose this is the two charge particle. Now the charge particle, two charge particle placed at this position. And you know that this is theta, this is pi, this is phi, this angle is pi minus phi. This angle is pi minus phi, and the basic concept is that whenever the suppose this is the length of a chord. Basic concept of length of a chord is if it is r, this is r, this makes angle theta, this will be 2r sin theta. 2r sin theta by 2. Basic concept of chord. Because this is theta by 2. This is r sin theta by 2. This is theta by 2. This is r sin theta by 2. So total will be 2r sin theta. This is the basic concept. How to find out the कैसे हमको कर्ड को लेंथ पे कर्ड कैसे निकालना पड़ेगा in terms of radius and the angle between the two radius. So here the angle between this is the r and this is radius r. वो जो दोनों रेडियस के बीच में जो एंगल है ना वो थीटा माइनस फाई है. और जो रेडियस आर बीच में एंगल थीटा है तो लेंथ ऑफ ए कॉर्ड इज 2r sin theta by 2. Here the length of a chord, this is suppose the d is the length of a chord, and d is found to be this is the length of a chord. And d is found to be, this is d is to be length of a chord is found to be 2r. This is equal to this angle is pi minus phi. This is length of a chord is 2r sin. You can just apply this basic concepts mathematics. 2r sin pi minus phi by 2. And this is equal to 2r sin pi by 2 minus phi by 2. And this is equal to 2r cos phi by 2. So length of a chord is found to be 2r cos phi by 2. So whenever the charged particle dispersed from this position, the positive will experience a force in the along the lines and the two charges or the Coulomb's law में apply करना. So यदि टू चार्ज पार्टिकल में तो बीच में जो डिस्टेंस है ना उसका क्या वैल्यू है d इज इक्वल टू r cos pi by 2 और उसको फ्यू फोर्स कितना है फोर्स इक्वल अवे अलोंग दिस लाइन जो द टू चार्जेस सो फोर्स का वैल्यू क्या है f अप्लाई कूलम्स लॉ में अप्लाई क्या है सो f इज इक्वल टू 1 by 4 pi epsilon 0 q square by d square. But this is in the oscillation क्या है? Whenever the particle makes a simple harmonic motion, the amplitude of oscillation, if it is slightly displaced, the amplitude of oscillation is very small within 4 degree. So phi must be very small. For oscillation के लिए और SHM simple harmonic motion के लिए हमको एंगुलर फ्रीक्वेंसी निकालना पड़ेगा. तो एसएचएम के लिए सो cos phi, this phi is within 4 degree, it should be within 4 degree, phi is very small, so phi by 2 is very small, so cos phi by 2 is nearly equal to 1 because cos is very small, cos is nearly equal to 1. So d is equal to 2r cos phi by 2, 2r cos phi by 2, that is equal to 2r, nearly equal to 2r. So force का वैल्यू क्या है? You just apply the force का वैल्यू F is equal to 1 by 4 pi epsilon 0 q square by कहते हैं d square का वैल्यू 2r है, 2r होल स्क्वायर. तो F is equal to 1 by 4 pi epsilon 0, that is q square by 16 pi epsilon 0 cos. Here, this is r. The r है रेडियस है, वो तो रेडियस है ना. So this is the exterior angle. You just see the concept. This is r. You just this is phi. So this is r. This is r. So this is r. So that means this angle must be equal to this angle, because in this triangle, this is the exterior angle equals sum of the interior angles. So this is r means this is r means this is phi means this should be phi by 2 and phi by 2. This the exterior angle must be equal to sum of the interior angles. So exterior angle phi is equal to phi by 2. This angle, see, this is r and r. So this is r. So this is phi by 2. So this angle is phi by 2. This angle is phi by 2. So in this is the case where this angle is phi by 2. This angle is phi by 2. Just I have draw the similar diagram here. For better clarity के लिए मैं तो similar diagram बना दिया है. So this is R. Better clarity के लिए similar diagram बना दिया है. So just you think that this is the force. ये जो force है ना, this angle is phi by 2. So उनका जो component है ना, just this is the vertically opposite angle, Janet. This is the vertical opposite. This is phi by 2. This is phi by 2. So this is f cos phi by 2. This is f sin phi by 2. And this f sin phi by 2 is responsible for the restoring force के लिए. A restoring force के लिए F sin phi by 2 is responsible, which bringing whenever the charge particle initially placed at the equilibrium position is slightly displaced, F sin phi by 2 is responsible bringing it acts as a restoring force. वो तो restoring force जैसे काम कर रहा है, वो F sin phi bringing back to the equilibrium positions. And F sin phi is the F is equal to, that is called tangential. This is the tangential force. F the tangential force. Restoring force. Tangential restoring force is equal to F is equal to F sin phi. And you know that since it is since it is sin phi by 2, sin phi by 2. And you know that since the phi is small, for small oscillation, for SHM, phi is small, sin phi by 2 nearly equal to phi by 2. So Ft is equal to F sin phi by 2, F sin F phi by 2. So here Ft is equal to F sin F phi by 2. So Ft is equal to Ft, that's the tangential force, that the tangential restoring force, that is equal to F का value क्या है? F का value है Q square by 16 pi epsilon 0. Already we have derived it. Q square by 16 pi epsilon 0 R square into 5 by 2. And the force, tangential force is equal to mass into acceleration, tangential acceleration, and that is equal to Q square by 32 pi epsilon 0 R square into 5. And you know this tangential acceleration is equal to alpha into R. Then alpha is the angular acceleration and R is the radius. So that is equal to AT is equal to Q square by 32 pi epsilon 0 m R square into 5. Phi is the angular displacement. So that is alpha into R. This is the tangential acceleration is equal to alpha, that is equal to Q square by 32 pi epsilon 0 m R square into 5. So alpha is equal to Q square by 32 pi epsilon 0 m R cube into 5. So this is the angular acceleration. This is the angular displacement. So, and the restoring force and displacement are in opposite direction. So, not necessary to specify the negative sign. You know that the condition of SHM, in SHM का condition क्या है? Acceleration is directly negative or displacement. Otherwise, it is quite obvious. Because restoring force and acceleration, angular acceleration, angular displacement opposite direction. So, कोई necessary नहीं है minus देने के लिए, because it is quite obvious. So this term is, so alpha is proportional to omega square. 55. This is the condition of SH. This is the angular acceleration condition of SH. So this term is the angular frequency omega square. So alpha is equal to omega square. So omega square क्या value क्या है? Q square by 32 pi epsilon 0 m. So this is the required answer. Square of the angular frequency. Answer is B. Answer is into very important question. This is the JEE Advanced में 2024 में PYQ में ये तो पूछा था. So very simply we have solved it. Thank you very much.